Hi everyone, Assalamualaikum. In this video, we are going to continue integration by U substitution. We continue with example 6. Evaluate integration of 5x over x plus 3 bracket to the power of 4 dx. Okay. From the given question, this is division function. Okay. And we have integration sign here. So means we want to integrate. Okay. Be careful, never use quotient rule to integrate as in differentiation because sometimes when we have division function, student tends to use quotient rule to integrate, but actually there is no product rule, no quotient rule and no generalized power rule in integration. So be careful. Okay? In this case, we can use U substitution. Okay? Alright, when we use U substitution, first we need to identify U. Let's say we choose U equals to x plus 3, the function in bracket here. So after we identify U, we need to differentiate. So we get du over dx. We differentiate x plus 3, so we get 1 here. Then we write dx as a subject. So we cross multiply, so we get dx equals to du. Yeah. So every time when we use U substitution, first we identify U and then differentiate and then write dx as a subject. After that, we rewrite the given question in terms of U and du. Okay. So from the given question here, okay, we replace x plus 3 from here equals to U. Okay. And we replace dx from here equals to du. Okay, we just replace u and dx. Okay, from the given question. Okay, and then we still have 5x in numerator here. So we can move out constant. So we get 5 and then integration of x over u to the power of 4 du. Alright. We can move constant 5 here from integration sign. But be careful. We never move out variable from integration sign. Variable means x, y, and so on. Right? So we never move out variable from integration sign. Okay? We only can move out constant. Alright? So how we can eliminate variable x from numerator here? Okay? Alright, from u equals to x plus 3, we can write x as a subject. So we move positive 3 to left hand side. So we get x equals to u minus 3. Right? And after that, we can write 5 and then integration of, alright, x here we replace by u minus 3. Okay? And then at this point, we have all in terms of variable u and du. Okay? Alright. So x here we replace by u minus 3. Okay? Alright, if we make the right choice of u, we can simplify or eliminate all the variable x from the given question and it easily can solve the integral. Okay? From here, we can integrate. But before that, we have single term in denominator here. So, first we need to separating the fraction. Alright. So, after we separate, we get 5 integration of u over u to the power of 4 minus 3 over u to the power of 4. And then we need to simplify using the properties of indices. Okay. Then we get this. Okay. So, from u over u to the power of 4, we simplify using a to the power of m over a to the power of n. So, we have a to the power of m minus n. So, from here, u means u to the power of 1. So, means 1 minus 4 equals to negative 3. So, that's why we get u to the power of negative 3 after we simplify. Okay? And then, to write 3 over u to the power of 4 using properties of indices, we can use this formula. Okay, we move up, then we get 3 to the power of negative 4. Alright? Okay, after that, now we have all in terms of variable u and du. So we can integrate with respect to u. Okay. So after we integrate, we get this. Okay. How we get this? Okay, from u to the power of -3. After we integrate, we use power rule. Okay. Okay, this formula valid for n not equals to -1. So here we have n equals to -3, which is not equals to -1. So we can use this formula. Okay, when we use this formula, we must add -3 and 1. Okay, so we get u to the power of -2 and then over n plus 1 means over -2. And then minus, we still have constant 3 here. And then to integrate u to the power of -4, we still use the same formula. Alright. So from u to the power of -3, we get this. Okay, after we integrate. Okay. And then for u to the power of -4, after we integrate, okay, using the same formula because our n not equals to -1, so we use power rule for integration, so we get this. Okay, we still have -3 constant here. Okay, and 5 outside integration sign. Okay, we still have -5 here. Then after we done integrate, we must put plus c at the end. Okay, because this is indefinite integral, no lower limit and upper limit. Okay, so we need to put plus c at the back. Okay, alright, after we integrate, from here, we can simplify -3 here and -3 in denominator. Right? And then we have 5 and then we move down negative exponent here. So we have negative comes from here, negative, and then 1 over 2 here. And then u to the power of -2, we can write u squared. Okay? And then negative times negative, or negative divided by negative equals to positive here. And then no more 3 because we eliminate here, because we simplify here. And then we move down u to the power of -3. So we get 1 over u cubed. Okay, and then plus c. Okay, so after we done integrate, okay, then we can replace back u equals to x plus 3. Okay, so after we replace and we expand 5 inside bracket, so we get -5 over 2, and then we replace u by x plus 3 and then bracket squared. Then plus, we multiply 5 and 1 over u cube here, so we get 5 in numerator, and then over, we replace u by x plus 3, and then we have cube here, and then plus c. Okay, this is the final answer. Okay. Coming up next, more examples for integration by u substitution. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.